Welcome back. I'm joined now by CEO of Plymouth Rock Technologies, Dana Wheeler. Plymouth Rock trades on the Canadian Securities Exchange under the symbol PRT. Dana, welcome.
Thank you.
Dana, quick overview. What is Plymouth Rock Technologies all about?
We actually are developing fairly novel threat detection systems.
Okay. What kind of threats and in what kind of environments?
A couple different threats. Threats for military threats, for people in checkpoints coming into forward operating bases, looking for suicide bombers, looking for hidden weapons underneath clothing, knives, drugs. A lot of different, we're trying to screen covertly so people really don't know that we're screening them, that type of things. Okay, and
what is the essence of the technology? What kind of technology is it?
So we utilizing microwave and millimeter wave technology, which is frequency spectrums below visible light, fairly small wavelengths, so we can penetrate clothing and we can see objects underneath using imaging techniques.
So would this be comparable to, for example, a Patriot 1 technology that does this sort of tag and follow technology where they detect it using microwave technology?
It would be comparable to them, but there is some differences in that we have longer standoff distances. So there you have to walk through a wall, both sides of the wall are kind of scanning you in close proximity, where we're trying to do something at more of a standoff distance. So in the case of a suicide bomber walking into a crowd or walking through a portal, it's almost too late when they're that far, into the crowds or into the portal at a gate at an airport, for example. Whereas we're trying to get them as they're coming out of parking lots, going into the venue, whether it be an entertainment venue, sporting events, that type of thing.
Interesting. And what stage of commercialization is your technology at currently?
Well, we have 3 different technologies we're looking at that all serve different purposes. We have a shoe scanner technology for obvious reasons to try to get throughput through the airports and detect impactions in people's shoes. Now in most airports in the world you have to take your shoes off. As you know, it slows down the lines. So we're trying to put together, we actually have some technology, we have some intellectual property that you stand on a certain area and it will image the bottom of your shoes. And basically we'll have some algorithms written that can actually tell us whether the image is a good shoe or whether there's something that's been done to the heel of the shoe.
A bad shoe.
A bad shoe. Well, it's funny you say that because we also have commercial opportunities to work with shoe manufacturers, to see if their shoes are being made properly also. By taking a good shoe signature and then a bad shoe signature. And a lot of that happens visually or by cutting the shoe apart, and then they sell them as seconds usually.
Okay, so what is the sort of public-facing the earliest sort of venue that we're going to see this technology at work in public?
I think the shoe scanner is probably the head of the crowd because we've done a lot of academic work there. We've done all the research, so now it's more of a development program, more commercialization of making the apparatus fit into a certain area, more mechanical engineering, so to speak. So I think that's going to be the first one that we're going to see out in public, doing demonstrations with some of the big companies that already provide screening techniques. For example, the L3 Provision machine that's in airports today that you have to go through the portal, stand there for a couple seconds. We can envision our shoe scanner being in that portal where you step on the yellow feet, so your shoes are being scanned at the same time your body's being scanned.
Interesting. That's coincidental that I just went through that process on Tuesday.
Oh, you did? Okay.
And I walked through the scanner, and the guy said you got to take your shoes off, which I thought was, well, I thought this whole thing was able to, that was so I didn't have to.
No, actually, we just talked to some folks that they didn't realize that either. That type of scanner basically puts a cylinder around your body, but it's not looking up at your shoes. Even the tops of your shoes, very difficult to make a detection there.
Interesting. Okay, then how much money have you guys raised so far? How much are you going to need before you get to profitability?
We've raised about $3 million to date, and we feel that we're going to need another $5 to $8 million before we can actually start producing these in some low quantity volumes, what we'll call low rate initial production. And that's going to take, that'll be into 2020.
Okay, great. Is this something that the larger defense contractors would have an interest in taking over?
Absolutely. Okay. That's one of our objectives.
Right.
I've had other companies that we've done similar types of security products where we've worked directly with the military for protecting forward operating bases, as I mentioned before, at standoff distances, checkpoints, for special operations, mobile special operations where they set up security checkpoints in different areas. So we see them adopting it fairly quickly because the technology is fairly novel and it's working very well.
Do you have a sense of how much it's going to cost per detection location for a buyer of the system?
I kind of have an idea of where it's going to be, where it has to be. We have to get the whole system, you know, through its user interface and everything. And well below $50,000. Well
below 50,000.
Yep.
Okay. Now, is this something that is portable, or is it a fixed stationary item?
It can be both. It can be portable. And one of our technologies, we're actually mounting a millimeter wave imaging system that will scan people on a drone.
Oh, wow.
So we're going to fly the drone above unstructured crowds and make detections with video cues on who has, for example, suicide bombs or any weapons on their body.
Well, very interesting.
Yeah.
Okay, well that's great, Dana. Very interesting technology, and certainly we've seen those have success in the past in the marketplace. So we'll continue to follow the story. Thanks very much for joining us today.
Oh, excellent. Thank you very much.